Okay, now this is what would normally happen. Now you know right now that you have to do long division because it's in that section in Khan Academy, that section that says do long division. Okay, but what if you didn't know it was long division? I know what you would do. You would do what any rational person would do. You would be like, okay, u equals x plus 4. And then you try it. You're like, okay, then du equals 1 dx. Oh, that doesn't help me at all. It doesn't. Because you sub those in, it doesn't help you. You can't get rid of all the x's. So that one doesn't work. Then you try the other one. You're like, okay, well, what about the 5x plus 5? Maybe that'll work. You do the du, and that equals 5 dx, and it doesn't. It doesn't work. You sub these in, and you realize, oh, shoot, none of these work. So what you're going to do is you're going to do manipulation. You're going to manipulate the integrand. You're going to manipulate what's inside of our integral, okay? And in this case, we're going to use long division. What? Long division? Now, let me recap what you do when you do division, okay? So, like, let's take 25 divided by 3. You remember that, the fraction stuff? Okay, back when I learned this, I would draw like a little thing right there, the division bar. But anyways, I'm going to just write it more cleanly. Okay, so 25 divided by 3. Now, when you do this, you go, oh, 25 divided by 3, that would be 8. And you're like, yay, 8 times 3, right? You go 8 times the 3. You get 24, subtract, and you get 1. So what's my answer? Now, if you had an elementary school teacher that taught you R1, remainder 1, that was like the worst thing to teach students. In fact, what you should have done is you should have said plus 1/3. Okay, that's what's left over. What's on the bottom goes on the numerator, and whatever you're dividing by, that goes on the denominator. Okay, so you know that 8 plus 1/3 is actually, you can rewrite that to just be 8 and 1/3. This is the answer. This is the same as this. They're the same. Okay, all right, so how can we use that algorithm, that division, to help rewrite this nasty dude right here? I will show you. So x plus 4 goes on the bottom, and then we're dividing that by 5x plus 5. Okay, so back in algebra 2, you learned how to divide polynomials. And when you divide polynomials, what you do is you focus on the first terms, and then all the other terms just kind of follow suit. And so we go x divided by 5x. And then we write the number on top. So what would that be? What is x divided by 5x? So I'm going to write that on the side. X divided by 5x. Well, 1x divided by 5x, wouldn't the x's just cancel out and you'd be left with 1/5? Yes. And so you're going to write 1/5. Now, whenever you write the number on the top when you're doing polynomial division, since this doesn't have an x value, I like to write it over the number that doesn't have an x value as well. You don't have to do it this way. That's just the way I like to do it. It kind of helps me stay organized. Now, just like we did down here, we took that 8 and we multiplied it to the 3. And so right here, we're going to take this 1/5 and we're going to multiply it to the 5x plus 5. But it's kind of like you get to distribute, so it's like you're multiplying twice. And so what we get here is x plus 1. Then we're going to take that and we're going to subtract it, just like we did down here with the 24. Okay, but again, we're doing polynomials here, and I don't like messing up with my negatives, so I'm going to go ahead and distribute that negative and just add these dudes. So I get 3, and then x plus negative x is 0, so I'm left over with 3. So what do you do with your remainder? That's right, you go plus 3 over whatever you're dividing by. So now we have a new integral. It's a little prettier. I mean, you guys might not think so, but it is more doable. It is palatable, okay? Now I'm going to do a little bit of extra. I normally wouldn't do this, but it'll help you guys see stuff. I'm going to do the integral of 1 over 5 dx, and I'm going to add to that the integral of 3 over 5x plus 5 dx. The first one, really simple. All you get is 1 over 5x, and then you plus c. Why? Because it's an indefinite integral. This guy, oof, use substitution. Are you guys ready for this? Oh, man. Now, I'm going to go ahead and take out this 3 and make him into a 1 because he's a scalar. Just put him out in front. Now I have 1 over 5x plus 5. Oh, use substitution. We're going to have to get another color for this. All right, u equals, I'm going to say probably 5x plus 5. And then that means du over dx would equal, what would that equal? That would equal 5, right? Because the derivative of 5x would be 5. Derivative of 5 is 0, so he goes away. And so du equals 5 dx. Now we have another issue. Okay, now I see where I can take out 5x plus 5 and put the u in. So this is going to be gone. I'm going to put a u right there. This is going to be u. Okay, but what about this dx? I don't have just a dx. I have a 5dx. Now the way I like to do it is I like to try to make this look like this so I can easily sub it out. I kind of wish this guy was a 5 because then it would just be, this would be 5 dx right here, and then I can easily sub in the du, take out the 5 and the dx, and booyah, I'm done. But there is no 5, and I even took out this 3 right there, so this would even be uglier if I left that 3 right there. So what do I do? What do I do? I'll tell you what I do. I'm going to take this 5, and I'm going to multiply both sides by 1/5. So now I have 1/5 du equals dx. Now I just have a dx, so I have to sub in the 1/5 du. Oh, okay, so we keep on writing. Man, I had to take a breath right there. That's a lot of stuff. We have 1 over u, and then I'm taking out the dx, and I'm putting in 1/5 times du. Now I'm going to take this 1/5, I'm going to take him out because he is not a variable, he's a constant, he's a scalar, multiplying to the 1 over u, and so now I have 3 over 5 integral of 1 over u du. Ooh, man, that's ugly. Look at all that stuff we've had to write so far. Now what is the integral of 1 over u? You should know this, natural log of u, the absolute value of u. Then you have your plus c, you have the 3 over 5 out in front, and then don't forget our friend up there, plus 1 over 5x plus c. Hey, we have 2 constants. Let's just add them together and make a new one. Yeah, okay, so just plus c, another constant. All right, and then I think we're done. We just have to rewrite our answer by taking out the u. Now we know what u equals. It's that 5x plus 5. So let's plug that stuff in. So we have 1/5 x plus 3 over 5 natural log of 5x plus 5 absolute value bar. Ooh, let's double check that. Yeah, there it is. 1 over or 5x plus 5. And then you have your plus c. And that is your final answer. And that was, my students, a lot of work. Let's see. This is our answer right here. Wait a second, Mr. Patey. You have 5x plus 5, but the answer says x plus 1. Now, there is a workaround to make sure this doesn't happen. I'm sorry that it happened on mine. That was a pretty gnarly problem. But here, let me show you really quick. Now, some of you guys might not remember properties of logarithms, which might hurt you right now. But we can factor out 5 inside of this natural log. And if you remember properties of logarithms, when you have something multiplying to something else inside of a log, you can change it to addition by writing the log twice, so natural log of 5, and then plus, actually don't need the absolute values because 5 will always be positive 5, and then plus c. Now you're like thinking, well, what the heck? What are we going to do with that guy? Well, this guy is a constant number. It has no variable in it. And so what happens in calculus is he just gets teamed up with this constant right here. He gets kind of swallowed up by that c. And so now we have the exact same answer as what was written in the multiple choice. Now, you might be wondering, well, I don't like what you just did there, Mr. Patey. How can I make sure that doesn't happen? Well, you can go back to the very beginning and you can look at the integrand and see if you can factor anything out of it. So look at the numerator. Nope. Look at the denominator. Yep. And so factoring out a 1/5, then you would have x plus 4 over x plus 1 dx. And so this is actually the same exact problem as that. And now if you go through everything we just did, you'll end up getting the same thing as one of the answer choices, and you don't have to use the properties of logarithms like I did down below. Okay, so just to recap, you would do the division, you would rewrite the integrand to look like whatever your result is. This is the integrand. So you'll have this. You can separate them and then simplify, do U substitution, do all of that stuff, and then you'll end up getting the same answer right here, this guy. Okay?